Hello everyone. In this session, I'd like to explain the Chandrasekhar mass. In white dwarfs, the degeneracy pressure of electrons balance with the gravities. Typical mass of the white dwarf is a solar mass. The radius is the Earth because of the degeneracy pressures. Polytropic of the index is 1.5. So if you substitute the 1.5 into the radius and mass relations, power index is minus 1 over 3. From this equation, you can calculate average densities. Average density is mass divided the volumes. Volume is proportional to the R cubes. Then you can substitute this mass is then average density is proportional to the square of mass. So density, average density of a star increases with the mass because the radius is decreasing with increasing mass. Then we can draw the graph. A vertical line is the average density of a stars, and the horizontal line is the mass of the stars. If the mass is increasing, density is increasing, and then at some point, when the density of a stars becomes 3 million gram per cubic centimeters, pressures of the degenerate gas is transient to the relativistic degenerate gas because of the high density of gas. So we have to switch the equation for the degenerate gas to the relativistic degenerate gas. And the polytropic index is changing from the 1.5 to the n equals 3. If we use the n equals 3, there is only one solution for m, uniquely determined by k. So I have explained when I derive the relation between the mass and the radius. I'd like to show you the equation for the mass is related equal 4 pi m sub 3 k over pi g, and the power index 3 over 2. I have explained. And in the case of the relativistic degeneracy pressures, it's Hc over 8, 3 over pi, 1 over 3, 1 over m sub h, mu sub e, 4 over 3, rho 4 over 3. Then this part corresponds to the k. This k substitute into these equations. And then you will get m sub 3 square root 1.5 over 4 pi hc over g m sub h 4 over 3, 3 over 2, 1 over mu sub e squares. This is the mass. We call the Chandrasekhar mass. So this corresponds to the Chandrasekhar mass. So if we increase the mass of the stars, pressure of the stars can be expressed with the degenerate electron gas pressures. But mass of a star is increasing. Pressures is changed from the degenerate pressure to the relativistic degenerate pressures. We cannot increase the mass anymore because the mass is uniquely determined by k. So this mass we call the Chandrasekhar mass. Chandrasekhar discovered this limiting mass of a white dwarf. Due to this discovery, he won the Nobel Prize in Physics in 1983. Actually, no white dwarf is known with a mass exceeding this mass limit. Okay, this is the end of this session.